Hey there, welcome to Level 2 Electricity. I'm going to get you started by asking a couple of questions. Here's one people have asked for millennia. What causes lightning? Why do giant sparks shoot through the sky on a stormy night? Here's a question people haven't asked for quite so long. Why does your dog's fur stand up like this after it's rubbed against fabric? In case you're curious, rabbit fur is the best for producing this effect. Well, this is where things get interesting. Lightning and your dog's standing fur are created by the same thing, static electricity. It's all to do with charge, one of the most basic features of matter in our universe. You should recall that matter is made up of atoms, which are themselves made of tiny particles like electrons and protons. Electrons have what we call a negative charge, and protons have a positive charge. Positive is the opposite of negative, so we say protons have the opposite charge to electrons. Opposites actually attract each other, meaning that if you leave a proton and an electron in a room together, they will move closer over time. We can measure charge, and it has units of coulombs. These have a capital C as their special math symbol. Now the important part. Any charged particle can have something called an electric potential, and that is an energy-related concept. Let's have a look at potential in detail. Imagine you have two straight rods, like this red one and this blue one. Let's not worry about what they're made of or how big they are. None of that matters for this explanation. All we need to know is that the rods are electrically charged. Say the red one has a positive charge of 1 coulomb, and the blue one has a charge of negative 1 coulomb. The rods have exactly opposite charges, but let's say we're holding them still so they can't move toward each other. Now we take two particles, 1 and 2, and hold them between the rods like this. Particle 1 is next to the positive rod, while particle 2 is chilling out by the negative rod. The particles both have the same charge, so they are identical. The only difference here is their position. The position of a charged particle affects the energy associated with it. Imagine that being close to the positive plate represents a high energy position, while the negative plate is a low energy environment. Then there's a difference in energy between the particles, which we will label like this, delta E. The energy associated with the charged particle tells us its potential. This quantity is measured in joules per coulomb, so it's energy per charge. Real particles don't have charges of exactly 1 coulomb, so you usually need a calculator to work this out. Potential difference is a difference in energies, and that's what the delta E refers to. It's really just one potential minus another, the difference between high energy and low energy for a given charge. And now for the really cool part. You don't need any particles at all to have a potential. In fact, the potential difference exists in any place where there's a difference of charge. These two rods have opposite charges, and the whole area between them is a potential difference. You can measure electric potentials in that area without directly measuring any particles. This leads to the idea of an electric field, which I will be covering in the next video. For now we need to know one more thing. The term potential difference is a bit clunky, but we have a better word for it. Voltage. If you've ever heard the phrase high voltage, this is where it comes from. When you have a voltage, you have electricity. Remember that potential is measured in joules per coulomb, energy per charge. Voltage still has these same units, which gives us a nice formula. V equals delta E over Q, where delta E is the energy difference between 2 points in an electric field. The little q is our symbol for charge. A small voltage is created when you rub fabric through your dog's fur, and the two end up attracting each other. That's why the fur stands up, and you can even get pieces of paper or balloons to stick to it. Be careful with large voltages though. Lightning is caused by a massive voltage that builds up between the ground, which becomes positively charged, and negative charges in storm clouds. Those amazing flashes you see happen when the voltage gets too high for the air to handle, and all the negative charges jump down to Earth. Next time, I'll explain what an electric field is and how to generate one. See you then.